Well, y'all had stuff to do. We'll see if you finished it, because here comes daily quiz mode. Get 'em!
This should be easy.
Mr. Sullivan. I am done with mine. May I please go wash my hands?
Yes.
Thank you.
Still going. Normally I'll take like 5 times that. All right.
Sorry, I'm still working.
Ah, there we go. A reminder for anyone who thought they were coming down during Spartan time, I'm not here today. Be back for game club. Just got to go run for an appointment. But I think most of you, if you had to take care of something, was that last quiz. And I know a lot of kids have been taking care of business either in Spartan time before this or your case manager's been hunting you down. Today should be 4-3, right? 4-3, 4-3B Monday. And then quiz on Wednesday. So on Wednesday next week, you will have your next test. Turn in your notebooks again. You will not need them. And you get to go into a 4-day weekend free and clear of math if you have taken care of business up until that point. Okay, you should have the handout from last time and then your book completed through 4-3. Okay. I'm going on 11 minutes or so here for a problem. I got to get going. Okay. Y'all remember your invisible one, right? And we said, like, collectively, I think the whole group said, I don't like the way the book did it. There, take this minus this and that minus that and that minus that in parentheses, and most of you just didn't like that. What most of us preferred was instead distribute and then use our boxes. So that's exactly what I'm going to do. Say 6xy plus 2x squared minus 3y squared. Negative 1 by 8x squared is a negative 8x squared. Negative 1 by a negative 12y squared is plus 12y squared. Negative 1 by 5xy is minus 5xy. So we do that so we can get rid of all of our parentheses and not have to worry about the signs or anything. Then what?
Then we do boxes.
Boxes. Every time you see a plus or a minus, Fruit Ninja. Wacha, 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 wacha. Do you know the wacha is actually a military weapon?
Actually, yes. What is it? Is it like...
If we do good today, I'll bring up the video of it. Mythbusters made one, and it was freaking awesome. Okay. I make all my boxes, and then I see which ones can go together. Well, xy goes with xy. What's 6 muffins minus 5 muffins? But they're not muffins, they're xy's. Now I don't put the 1 in front of it, right? 1 xy is just xy. And then, most of us, we're doing something to cross them out so we didn't accidentally use them again, and we knew that we used everything we were supposed to. Then, do I have any other x squareds? So what's 2 chalupas minus 8 chalupas?
-6.
So negative 6 x squareds. I keep saying dumb things in place of the variables because I want you to get this through your head that it's 2 things minus 8 things. The things doesn't cancel. The things don't change. You can't say x squared minus x squared is no more x's. Okay? It is negative 6x squared. And I will cancel those out so I don't use them again. And finally, negative 3y squareds plus 12y squareds is 9y squareds. Now, did anyone have these three things but in a different order? Okay. So long as you have the same thing in the same spot. Okay. Could I have done that? And then I just say plus because it was a positive. Right? I could have, oh, get over there. Now you want to put those together? Screw you, dude. Frank, you know, there's days, Frank, where you and me just untangle. One of these days, Sullivan's just going to lose it and put this coffee table through his smartboard.
That'll be awesome.
Okay? Like, you all seen the gif of the dude in the big panda suit that just starts wrecking that dude's computer on his desk? It's me and Frank. It's coming one of these days. Oh, I'm sure it'll be on YouTube. So, did you get, I'm just going to say each of these terms was a thing. I'm going to say, do you have your box or some sort of organization to back it up? Did you take care of your negative 1? Okay. So it's basically 3 for the answer and 2 for the organization or work to show how you got there. Even if you can do some of this in your head, that's one thing. Believe me, you ain't going to do them all in your head. Some of these are going to get bigger and uglier. Yes, sir. Double check something.
I just didn't do the thoughts.
Oh, no, you're fine. You distributed a negative, you showed it, and then you combined the ones that you needed to. You're good. Yeah. I just need some method of organization there to show that you're not winging it or copying your neighbor. You got your negative 1, you change your signs, and then, yeah, you're fine. You're fine. I need something to show that there was a method of organization. Okay? In fact, tell you the further we go through these, and you're going to see this as we move into the next couple of, maybe even today. Another way to do this, not you, not you, not you, is what I'll see some people do is they write 6xy to x squared minus 3y squared. I'll see some people that when they distribute, they'll just write that under the other term that matches it. When they distribute, they'll write it under the term that matches it. When they distribute, they write it under the term that matches it. Because now, look at that. Now look at it. If as I'm distributing, I remember, well, this is going to go with this anyway. Do you see how everything's nice and lined up now? It almost looks like, rather than one big, long, ugly problem, it's 3 short addition or subtraction problems. It's just a different method of organization.
I should put mine. I set mine up like it was in the book.
That was just a different way to organize it. It all depends on which way you prefer, which way you like. As long as you get the answer and you got work that isn't just make crap up. Yes. You have to follow math law. The example that I always use is if I asked every one of you, how do you get from Your car's parked out in the parking lot. How do you get from here to Walmart?
You walk.
Okay.
Take the freeway.
And people are going to have different answers, right? Like someone's going to say, I don't have a car. I'm just going to walk over there. Or I'm going to ride my bike because you got that trail that cuts across, right?
Oh, yeah. I used to ride my bike.
Someone else is going to ride they're going to drive all the way down the main drag, go out past Dairy Queen and stuff, see if that 1Q kid's working. Stalking on people. I know y'all do that. You're going to have someone else who does main drag to Jackson, Jackson onto the interstate, and then over, probably the fastest. You're going to have someone else who says the in-town cops know my car and they hate me. I'm going to go north, get on the interstate, and go around town. Could you have gotten there by route of Deadwood?
Yes.
You got there. Did you follow the law on the way there?
Yeah, I'll go through the
Yeah.
canyon and
You can do that. Okay. So open it up 4-3. We needed a little bit of practice off to the side on 4-2, but 4-3, here we go. Now, a good chunk of you are in, you're all in biology, right? Have you done the Punnett square thing yet?
yes.
Punnett squares where it's like dominant recessive traits. You know, everyone like roll dice or whatever to see what kind of traits you're looking at, and then everyone make an alien baby. It all depends on who's teaching, right? Okay. And the idea would be something like you got Mama Bear has blue eyes, which is a dominant, actually blue eyes is double recessive. No, blue eyes is dominant recessive. It's green that's double recessive. And then green is like, instead of big G, little g, it's little g, little g. You do that and you figure out, okay, blue, green, dominant over recessive. Blue, green, dominant over recessive. Green, blue, double recessive. Green, blue, double recessive. Okay. What happens is you have a 50-50 shot of either having kind of bluish green puddle eyes versus just straight up blue eyes. Depending on, it's kind of a bluish green mix. It kind of, almost like kaleidoscope style. It's like a light blue with kind of fractals in it. It's pretty cool. Yeah. So if you've done something like that, what we're going to talk about today is different ways to multiply these polynomials. And one of them is to use that Punnett square from biology. Okay? Sort of. So I'm going to show you like 5 different ways to do this. Okay? You just pick the one that works for you. But the reason I'm showing you that is because there's something called Algebra Tiles. And I don't know how many of you have actually worked with these before. Okay? If any of you do like individual work with Miss DuPont, I know sometimes she'll break these out where we're just really struggling on how to do stuff, but if you get it physically in front of you, now all of a sudden I get it. Okay? The idea is a big tile length by a big tile length is x by x, so we call it x squared. A big tile length by little tile length is a x by 1. So it's 1x. So if I'm taking 2 x's times a thing, that means big tile, big tile. If I'm taking x plus 5 times a thing, that's big tile, little tile, little tile, little tile, little tile, little tile. And then you line them up. Big and big. X times x is x squared. Big and big, x squared. Little is 1 by x is 1. So here's 1x, 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 1x. And then you could just count them. You can physically put the tiles in front of you and you can count. If I take 2x times x plus 5, it's 2x squareds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10x. This is 2x squared plus 10x. Some people, if they get that physically in front of them, that's the make or break. That's what made it work for them. But others, do you remember just regular distribution? Right? 2x times x is 2x squared. 2x times 5 is 10x. So I'm saying these tiles are a backup option if you're just getting super, super stuck. I know Mr. Pont has one. I think y'all got a couple like in the different rooms. I think I have one set hiding somewhere in the midst of all of these games. I would have to find it. It's a different way to multiply. Where things are going to get dicey for us now is before I was doing easy stuff like 2 into x minus 3. 2x minus 6, right? Well, now I'm going to be taking an x times an x. Do you remember your exponents from all the way back in September?
No. Kevin does.
Kevin's got that little note card. So this is going to be distribution, our add and subtract polynomials from the other day, and a little bit of our exponent stuff from the beginning of the year, all mushed together. Because polynomials sometimes get complicated. Over here, you got this space. In that space, I want you to write our rules for exponents if you do not remember them. Kevin, if you would please, rule number 1. Anything to the 0 power is 1. Rule number 2. You know what? I'm going to do here. 1, 2, 3, 4, 5. There we go. We'll go rainbow style. So, anything to the 0 power is 1. Next up.
Any exponent, any variable with exponent times another, you add the exponents together.
If I ever have x to the a times x to the b, this is the important one that we're going to see a lot. I take x to the a plus b. Remember, when I multiply exponents, I add them together. Everything gets downshifted. Okay, rule number 3.
Open parenthesis x to the power of a plus parenthesis and b on the side equals x a times b.
Okay. If I have a exponent, hey, if he's got it, he's got it. I didn't know if anyone else kept their notes from first semester. Some of you just plain burned them. Okay.
I have a number format, so like I have it as put open parenthesis x to the power of 3 plus parenthesis to the power of 4. Yeah,
Okay.
That's what I have.
Yep. As well. So we had a bunch of different of them. And then the next is if I've got more than one thing in there, x to the a, y to the b, and they all get to the c. Everyone gets that exponent, and since they're all to an exponent, they're all getting multiplied. X to the AC, y to the BC. Then we had division. If I ever have x to the A over x to the B, I subtract. If I ever have, where'd you go? More than one thing in there, x to the A, y to the B, all to the C, again, they also get that. It's x to the AC over y to the BC. And 7. So there was multiplication, exponents, division, what?
5 was any any variable, and I put -2 equals 1/2 or 1/2.
Oh, gotcha.
X squared. So
So I just got my rules a little out of order. It doesn't matter. They're just, okay, so in there we'll have, if I do x to the negative a, I get 1 over x to the a, or 1 over x to the negative a becomes x to the positive a upstairs. Remember, the negative acts like a light switch, upstairs, downstairs? Okay, so these were our rules for exponents. I bring them up because when we're multiplying now, we're going to have to remember when right next to this, kind of a big deal, when you add or subtract exponents, no change. When you multiply or divide exponents, then it follows these rules. And that was something that I think we were having a little bit of trouble with and why we took an extra day for 4-2. If I say 5x squared plus another x squared, it's not magically 6x to the 4th. When I'm adding or subtracting, exponents will not change. It's only multiplying and dividing that exponents change. And that's super important for us to remember as we move into this section. Because now we're going to do distribution. We're going to distribute, and sometimes when I distribute, I'm going to have a big pile of alphabet soup in there. There's going to be variables and exponents and coefficients, and it's like someone took your box of alphabets and just on the table. Okay, it's going to have a lot of stuff going on, and we got to remember these rules if we're going to do that. So, we're good? All right. So down here, we're going to start with basic distribution. If I take 5x times 3x to the third, do you remember what 5x times 3x to the third is? How I do the parts to it? Okay, you got to be careful. There's a little invisible one here. But what you are adding matters. The x's go together. I'll say x to the first times x to the third. 1 plus 3 is x to the fourth. But here, this is 5 times 3. 5 and 3 are not exponents. So they don't follow exponent laws, they follow regular number laws. What's 5 times 3? Okay. If I say 5x times 12x.
you put x to the 4th up there.
I know.
That's the third.
No, it's not. Exponents follow their own laws. X to the first times x to the third. Rule number 2, 1 plus 3 is 4.
I got mixed up.
That's why we're reviewing that, because exponents have their own laws, coefficients have different laws. Where they are determines what set of laws they follow. Okay? I lived for years in northern Arizona. We were sandwiched right in between the Havasupai, Hopi, and Navajo reservations. Northern Arizona. And I worked with a lot of boys. We worked with tribal social services. I had to remember that when I went on visits, or I took my boys on home visits, that there were different laws that we had to abide by on different sovereign nations. Exponents are their own sovereign nation. They have their own laws. You got to follow exponent law when you're up in exponent town. When I'm in coefficient town, I can follow normal laws. Okay? So let's try it again. If I take 5x times 12x, then I have to take the parts that go together have to go together. This is x to the first and x to the first. These are in exponent town. What do I do with x to the first times x to the first? I add their exponents because that is exponent law. And x squared. But 5 and 12 are in front of the variables. They are not in exponent town. So they follow regular law. What's 5 times 12?
16.
There you go. That's where these can get confusing, is because now you're combining, I already know how to do some of this algebra stuff, but I forgot how to do the exponent stuff, and what happens when they're doing them at the same time? Like, who can actually do the pat your head, circle belly thing?
I can.
Okay? Now, most people have been asked to do that a good number of times. Let's see where my drummers are at. Who can move your hand in a circle this way? Go ahead, like you just had a nice big cake. Num num. Okay? Now try moving your foot in a circle the other direction. Now try to reverse your foot. And your hand's like, right? Okay. Who can move your right hand this way, but your left foot the other way? Okay, now try to switch the direction of your foot without changing your hand. Okay, it's right and left brain. It's different parts of your body controlled. That's what's going to happen here. You're going to have regular distribution law with exponent distribution law, and you have to do them at the same time. That's why we're going nice and slow. So, all right, this is something you may not have seen before. This is called binomial distribution, and it has a bunch of ways to do the problem. Okay? The way that we're going to start with the way the book shows, and then I'm going to show you a couple different ones. Now, if I only had 4 smashed up on there, you all remember that. 4 is up on parentheses. Well, that's if I'm trying to solve it, if I'm trying to get it out of there. We would distribute, right? Well, what happens when it's not just 4 smashed up on it? When there's more than one thing smashed up on it? You're going to have to distribute both of them. So what I'm going to do is I'll take a b times b plus 5, but I'm also going to have to take a 4 times a b plus 5. You have to distribute both of them. Now these ones are nice and easy because it's only 2 things. I can show arrows over and under. So if I have a b times b plus 5, well, that's b times b, which is b squared. That's b times 5, which is 5b. I'm distributing b to both of these. So I'm taking b times b. Here, let's switch our colors up again. Yellow. This is b times b, and I'm also going to take b times 5. I also had to take 4 times 5. That's what it says here. Take 4 times both of these. 4 times b, 4 times b, 4 times 5, 4 times 5. Okay, they're writing out a lot of steps that you don't necessarily need to do. I'm going to do this a couple different ways, and you'll probably like it. No, it's not. This is the baby steps. This is the training wheels. I'm not just going to take my kid out into the parking lot, throw him on a bike, and kick him. Okay?
What about set your 3-year-old kid in a car and have him drive?
Like I'm gonna duct tape a 2x4 to your leg. I'm gonna put you in the driver's seat. You can't see over the edge. Whatever, dude. Have fun. No. Okay.
That's what my sister did.
Now,
Yeah, I was 5 years old. And she took
what is b times b? No.
B squared.
B squared. What's b times 5? 5 b's. Not b squared because there wasn't more than one b. It was a b times a 5, 5b. What's a 4 times a b?
4B.
And a 4 times a 5. Okay. So this is what I mean by you have to combine all of your different skills. Look at that line and think about what we were doing the last 2 days. Chop, chop, chop. Do any of those go together?
Yeah.
Which ones?
5 and 4.
What's 5b's plus 4b's? 9b's. And then b squared is still out front, and 20 is still at the end. Because Ms. Jeffrey really likes playing videos in class. Okay. Now, I would like for everyone, where your notebook that you have your daily quizzes in, pull that out.
I haven't done this in a while.
Well, you should have done daily quiz just today.
Oh, no.
Okay.
No.
We're going to get a sheet of notes, and we're going to do different ways to multiply. I'm going to show you different ways. And you're going to pick which one you like. Yes.
Do I have to say it out loud?
You're all going to decide which you like. And sometimes I use different ones, depending on what I'm doing.
How many? Like 5.
Arrow distribution, foil, box method, stacked. Probably not going to show you diamond method until we get to factoring. I'm going to say 4 for now.
I'm going to definitely do box.
Okay. So if I'm taking b plus 4 times b plus 5. I'm going to show you 4 different ways to do this. And everyone literally has their own flavor. Okay? So the first way that I showed you, and honestly, it's the way that most kids do it. If I say b plus 4 times b plus 5, here. Way number 1 says, I'm going to distribute. Okay? I draw my arrows, and I write their products individually. This is what we just did, but with less steps.
So that's
What's b times b?
2B.
No,
B squared.
b squared, remember?
Oh, okay.
Okay. I'll take b times positive 5.
B5.
5b, right? We always put the number first. and 4 times b. 4b. And finally, 4 times 5. Okay? So way number 1 is distribution with our arrows. Okay? I do have to be careful when I'm done that if I ever have like terms, I have to put them together. Okay. Next. FOIL. First outer, inner, last. First outer, inner, last. FOIL. It's an acronym. Remember PEMDAS?
Yeah.
Please excuse my dear Aunt Sally. Please execute my deranged adolescent sister. Whatever you were using. It was an acronym. An acronym is these letters stand for words. These words tell me what I'm doing. Okay? In this method, if I have b plus 4 times b plus 5, get your fingers out. I recommend these ones. Point to the first term of each binomial. What's b times b? Put your fingers on the outer ones. Inner ones. Put your fingers on the inner ones. 4b. Last. Your fingers on the last ones. And then combine like terms. Oh, get over there. Okay? So this first outer inner last thing says first is this, outer is this, inner is this, last is this. And then you combine like terms. Okay? First, outer, inner, last. If you notice, it was the same thing that we just did, but it's words instead of drawing arrows. It depends. There's a lot of kids who will do this while saying first, outer, inner, last. They'll do this and they'll say FOIL. First ones, outer ones, inner ones, last ones. Okay? So, your choice. The next one is called the box method. You make one of those little Punnett squares, just like in biology. And now I'll say b plus 4. I put those two terms right here. b plus 4. b plus 5, I'll put those two terms. b plus 5. And do you see how they line up just like our cheater chart? What is b times b?
B squared.
What's 4 times b? What's b times 5?
5B.
What's 4 times 5?
20. Oh, wow. I like these.
Okay? Everyone's going to have their own preference.
I like the foil.
Now, what is nice about this is your like terms, if you do it right, your like terms will always be on the diagonals. So that's a thing.
That's cool.
Okay? Hey, come on. And then the last one, old school stack multiplication. Do you remember, don't write this part,
Carry the one.
1 times 2 is 2, 1 times 1 is 1, 1 times 3 is 3, and then what?
2 times 2, 2 times 1, 2 times
Before that, sir?
turtleneck.
What?
You write a circle around the one and all the way up around the rest of it. And then in a different color, you wrap around the next one, wrap all the way around it.
Man, I should have.
Does this ring a bell to any? I just wanted a 0 as a placeholder. Turtleneck? Okay, all right. You cross this one out and you put a 0 as a placeholder. Because I'm not taking 2 times 2, I'm taking 20 times 2. So I have to shove it over into the 10 spot. Getting 4, 2 times 1 is 2, 2 times 3 is 6, and then you combine like terms. Huh?
Can you show us the diamond one?
Just wait.
I'm definitely not doing that.
But check this out. I do this with Algebra 2. X squared plus 1x plus 2, 2x plus 1. You see how the x's are lined up? 2x times 2 is 4x. 2x times 1 is, or 2x times 1x is 2x squared. The way that you've been multiplying these digit numbers is just distribution. If I take b plus 4 and b plus 5 and I multiply them together old school, I'm treating each of these as if it was a digit. What I'm doing is distributing. What is 5 times 4?
21.
What's 5 times b?
5b. 4b.
And then cross it out, 0 as a placeholder, b times 4. B times b. And you notice how they're all nice and lined up, just like our place values were. B squared plus 9b plus 20.
Yeah, I don't like that way.
Now that way works best when I have big ones. When I'm looking at like 4-term polynomial times a 5-term polynomial, then this method comes in handy. So you've got those methods.
Have at it.
Those are our different ways that we can multiply. Okay, so I see all of these are just regular distribution, but I have to know how to do my exponents. So I'm guessing the one that everyone is going to want me to do, when I ask around the room, I roll my die and I say, someone, which one am I doing? Everyone's going to say 6.
None.
Got 1,
2.
3,
4.
6, 5.
I will do 6 because it's the ugliest.
No, I think 5 is the ugliest.
Okay.
Good thing I'm not.
Step 1. Hey. Step 1. I'm going to take negative 5ab times 3a squared b squared. Oof, right? I'm going to put my 1s on the a and the b so I remember those are exponents. And tell me, Negative 5 and 3 are not exponents. They're in regular land. What is negative 5 times 3?
Oh.
15.
Okay, look at the A and the A. Now they're in exponent land. What is A to the first times A to the second? Nope. What do I do with exponent times exponent? I add them. A to the third.
Why does that sound like you're in a Pringles? How do you know what that sounds like?
Because he fell in one once. What is B to the first times B to the second?
B to the third.
Yes, because I add the exponents. Okay, do it again. Take negative 5AB times negative AB. The number parts go together. What's a negative 5 times a negative?
Positive.
A positive 5. What is A times A? Yep, A squared. I now have two of them. What is B times B?
B squared.
B squared. Coming a little faster? Do it one more time. Negative 5AB times 5B squared. Take the number parts. Negative 5 times 5.
What?
No, times. Negative 5 times 5. Negative 25. That's why it says minus 25. Uh-oh.
Oh,
A
no,
times
Raggy.
what?
Nothing.
There's no other A. So when I'm adding exponents,
Oh, you just keep.
I just got an A.
That's sad.
What is B times B squared again?
Huh. It's a little wonky. It's gonna be hard to get used to.
Yep, we got to get used to all the exponents flying around in there because sometimes you're in regular land, sometimes you're in exponent land. And you're going to have to use both laws simultaneously.
I don't like having to math right now.
Too bad.
You signed up for the class? Oh wait. Oh my.
You got 7 weeks. Lock it in. Okay? 1 through 5, get them. I want to see if you can distribute 1 through 5. All right, they're working. 3 minutes, I'll be back.
Two times what? 14. That's cool. It's 2 times 7. It's a calculator. No. I wanted to see its text. You definitely did not know that yet. No.
What's negative 4 times 9? I'm just testing. No, I know the answer. I'm just making sure you do.
No, I didn't know the answer. So I was asking you. I ain't ashamed of not knowing. I didn't pay attention to pre-science or middle school.
It's not black.
Just walking under. Blockade. Didn't you do that once? Just completely slammed on the table. No, it's just
It's like the Hulk with a tiny head.
So when it comes, like right here, when it doesn't have a I, so I multiply.
Yep, because what's kind of showing up there is there's a y to the 0. Because anything with 0 power is 1. And 1 plus 0 is 1.
Okay, perfect.
Yeah, that's exactly it.
Thank you.
Remember.
Finish that one and then Paxton, how about you, bud?
What?
It's going all right?
Yeah.
Well, good so far.
Thank you.
All right. What's up, bud?
This is a 5.
Okay. So this times this, you wrote it, times this, you wrote it, times this, you wrote it. Cool. So now, you take them in pieces. What's number times number? What's 4 times 2?
That's 8.
X to the first times x to the fourth.
That'd be x to the 5th.
Yep, you add those two together, get x to the 5th. Y, and see how there's no y here? Well, think of it as y to the 0. What's y to the first times y to the 0? Well, 1 plus 0 is 1. So it's just y.
Okay, so that'd be for all of them.
Yep. So what's 7 times 2?
So that's just 14.
X times x to the third.
That'd be x to the 4th.
Yep.
I can't
then
think
y.
of the exponent name for 4 for the 4th.
Quartic.
Quartic?
But
I know
that's
I
when
learned it.
that's when it's a degree 4. We don't have to worry about that here.
Okay.
Okay, and then 2 by 8.
It would be 16.
X by, well, nothing else, so just an x. Y times y.
Y squared.
Ta-da!
And
I forgot all the old date.
Okay. Need to check. Oh, wait, you got it down here. Okay. So the third, 14x, negative 37g. So positive 12g squared. Negative 5a6. Negative 6a to the. Whoa, we gotta check that one. Positive 3a to the fifth. Yep. Negative 3y to the third. 12y squared. Good. Yeah. Just that one. There you go. Blasted through it all.
Yeah. I also caught up on the stuff that I missed.
All right. Well, that's pretty much what we're doing. There you go. Come in handy, don't they? Yep. And that's why I just want to show you different methods. You use what works for you.
Are we gonna do trial theory get drafted?
I'm not sure.
I don't know if I got number 3 right, but all did it
And
twice, so.
times 14x, good. And negative, right? Because negative times positive. G. What's a. Oh, right here. See how it was negative.
I'm kind of getting
Negative times negative is.
positive.
Okay. And it's little things. Okay. That and that is negative 3y cubed. Good. That and that is 12y squared. Good. Negative 36. Looks good. Okay. It's little stuff. There's lots of moving parts here.
So shoot.
No. missed one. Looky, looky. Now, the nice part about multicolor mode like this is if there's anything up there that you're confuzzled by, you get to say what color, what problem. Like, wait a second, how did you get green on 4? Okay, it really helps narrow things down. So, check them over. Is there anything that you want to talk about, or did this actually not go too bad?
Not too bad. Mic drop.
Got a mic drop on it?
Wait,
And
is
It blows up.
I can't tell the difference between green. Is that green and yellow?
It's blue, green, yellow.
Someone walks out with a gray. Like just
I know.
Nothing?
no.
All right. Then we're going to move on and say, Bud.
I'm still copying it.
I hit finish.
Nah. You're going to have to get it from someone else, dude.
Good time for the man.
Okay, flip it over. Now, they want us to write it out with all those baby steps. Instead of all those baby steps, what I'm going to do is say, nah.
Thank you.
I'm going to say, okay. Instead, I want you to have, I'm going to do all 4 ways, and you're going to write down the way that you think, nah, that's my jam. Okay? Option 1. I'm going to do my arrows. I'll say 7x by 7x is 49x squared. 7x by 3 is 21x. Negative 3, see I make my arrow from the sign, times 7x is negative 21x.
And then
Negative 3 by positive 3 is minus 9. Can I clean this up at all?
yes.
Which terms can I put together?
21 and negative
What happens when I say 21 waffles minus 21 waffles?
0.
We get no waffles.
So it'll just be 49x squared minus 9.
Okay,
49.
that's option 1.
I'm doing
Option 2 is literally the same thing but with words. First, 7x by 7x. Outer, inner, last, and then combine like terms.
Yeah, I like that one.
So methods 1 and 2 are pretty much the same. Okay, one's just with words, one with arrows. But boy, do I have a lot of kids who will do the arrows while saying first, outer, inner, last. Foil. Okay. Next up, what if I did box? So now I'm going to say 7x minus 3, 7x plus 3. And in there goes 7x times 7x, 49x squared. 7x times negative 3 is negative 21x. 3 times 7x, positive 21x. 3 times negative 3 is negative 9. And then I see that my diagonals are like terms and happen to cancel each other out. So I'm left with 49x squared minus 9. Option 3. Well, 4, but like 3.2. Is I'm going to take 7x plus 3 times 7x minus 3 old school. No. According to all of Game Club, I don't know new school. I'm old. Negative 3 times 3 is a negative 9. Negative 3 times 7x is negative 21x, and then I put a 0 as a placeholder. I cross this out, and I start again. 7x times 3 is 21x, positive. 7x times 7x is 49x squared. And I have everything lined up by like terms anyway. So what's your jam? Method 1/2?
1/2.
Box method? Or old school? We'll call it distribute foil, box method, old school.
Distribute foil.
Okay.
Yeah, new one. For
The first one? Okay. You have a choice. I don't care which method you use. You do not have to write out all of those blanks that they do. And in fact, look at what they got going on. They didn't give you any blanks. So you might have to use the margin to multiply some of it out. Maybe you'll have to show your distribution like this, write 1, 2, 3, 4 terms, but then can you simplify it? Okay? So however you're going to do it, those 6. Distribute, foil, box, old school, get them.
And then Mythbusters.
What was that for?
And then Mythbusters.
I don't know if we're going to get there. Yes. Because we've got a little bit of distraction around here. What's up?
Is this doing? Am I doing that right?
No, you're only doing half the problem.
Half the problem? Okay, what am I doing wrong there?
Okay. This is 9x times 5x.
Mm-hmm.
It's 45x squared.
Okay.
9x times 4 is 36x. Then 1 times 5. Or 5x.
Yeah.
Is 5x. 1 times 4 is 4. I have no idea how you got these.
Combined like term.
Even that, like, even if that was addition, that's not how you do that.
Okay.
You need to write out those 4. Okay?
Okay.
That's where the box method might not be a bad idea for you, because if all the boxes aren't filled, you know you screwed up.
Okay. So, now do I just combine?
Now you combine like terms.
Okay.
And those two can go together.
Okay. See, I was adding these two because I didn't put the square up there. That's how I got.
Oh, okay. I didn't see that's what you were actually doing. Okay, and you missed your x over here too.
Mm-hmm.
So we're missing x's as we're going.
Okay.
Just slow down and make sure x times x times this.
Okay.
Okay.
Does that look good so far? Is that
Combine like terms. That's a 36x. Remember, it was 9x times 4. 9x times 4. This is 36x. And what's 36x's plus 5x's?
36 minus 5, correct? Not plus.
Why would it be minus?
I don't know. That's what I've been doing in previous problems. So you subtract a lot.
Here. Where'd red go? Do I not have red anymore? There's red. Well, it sounds to me like we can't bypass steps then. Remember this?
Yep.
They're both positive.
So I add them,
Yeah.
correct? Okay.
You're combining them. You're not solving. When you solve, you need to do the opposite to cross the equal sign, to cross the Paxton line.
Okay.
Okay?
And it ends up x not squared, correct?
Correct, because they only change if you multiply or divide. I have up there just the distribution, not the final answers. For those of us who like to just write down the final answer and then say we did it.
Okay.
Gavin, do them for real.
Uh, so
This is for you to check, not to copy and claim you did it.
did I do this right then? Because I wrote the definition things over there, and then it labeled it. That makes sense.
Oh, this is just a little, okay. Some of them yes, some of them no. Like on the first one,
Yeah.
that's 45x squared, 36x, 5x, 4. We missed the 4 entirely.
Okay.
You don't have your x squared there, and your 4 is not even.
Okay.
Poof.
Okay.
Okay, just slow down. Slow down. It's all right. So if you're combining like terms correctly, if you're 4.2ing correctly, then you should be able to have the final answer after these.
What did you multiply to get that? I said yes or no. One and what? And is there any signs in front of them? No, I'm asking. Is there any sign in front of here? No. Is there any sign in front of here? So then they're both positive. So yep. And then you combine these.
Okay. Which one did you write out? First one?
I did that one, but I don't know if it's right.
Did this one. Where? Which one?
Plus.
Oh, okay.
Okay, wait, what did we do for that one?
Okay, so you're missing your terms in the middle. You did first,
Oh.
and you did last.
This line first, and then you do this line.
Instead of FOIL, you did
I would draw the line slower.
you missed
You did in which order?
outer. So there's also a 36x, and inner. There's also a 5x. Okay? That's where the arrows help us. And the arrows or the box help us because if I don't have 4 arrows, I miss something. If there's a spot open in the box, I miss something. Those are helpful. Okay? And those are like terms, so what's 36x's plus 5x's?
1. Negative 1.
Okay? So in the middle, in between these, you're missing a 41x.
Plus 4. 1.
How many y's are there?
Okay? Write another one. I want to get one done before we got the bell here. Make sure that we're good.
We have one there. No, you were right. But I want you to show me where you saw those.
This one and this.
Okay. Just making sure. Now we need to simplify this. Who are the like terms? Who's like who?
24 and 1.
Okay, so what are we gonna do? Okay.
Okay. So we say 6 times 1. Or wait, is it negative 6? No, it's just 6. So it's 6 times 1. Write it. And then 6 times negative 4y.
And then
Who's attached to 25?
this one.
Who's attached?
Oh, y.
Okay.
Okay?
Okay.
And then we'll just tack a y on there. So minus 24y.
Squared.
Is there anything else we can do?
And then negative y times 1. Just negative y, yeah. So minus y. And then negative y times negative 4y.
Oh crap, I did it on the wrong.
Negative 4y, and see how it's a y and a y? What was y times y? Yep, y squared. So negative 4y squared. And then you chop them up. Are any of those like terms? Oh, this guy's a y and that guy's a y squared.
So then the 24y and then
Yep. You owe me $24. You borrow another $1.
so 6. Still 6.
Yep.
24
Because you owe me $25. Yep.
y squared.
No. Those don't change when I'm adding and subtracting.
So
It's just minus 25y, and you're done.
But
So 25y, and then throw him on the end. Okay? It is not homework. We will continue it on Monday.